Good morning, everyone, and welcome to today's hybrid seminar, Peatlands Futures, Integrating Data and Community Governance for Nature-Based Climate and Haze Solutions, organized by the Climate Change in Southeast Asia program at the IC's Yusof Ishak Institute. I am Gauri, your MC for today. In this seminar, we will be sharing and discussing key findings from 2 Asia-Pacific Network for Global Change research projects that highlight the importance of adopting an integrated approach towards haze from peat burning and climate change. Discussions will focus on the potential of utilizing peatlands as nature-based solutions in Southeast Asia and the challenges in doing so, particularly from data and community perspectives. The seminar will culminate in the discussion of a policy brief that foregrounds community-centered actions for improved peatland governance and nature-based solution outcomes across the region. Before we begin, please allow me to draw your attention to a few housekeeping matters. Firstly, please note that this seminar is not under the Chatham House rule and the recording will be uploaded on YouTube after the event. Secondly, we will be having a Q&A session. For the online audience, please submit your questions via the Zoom Q&A function, stating your name and affiliation. If you encounter any technical issues, please use the chat function to reach out to our technical support team. For our in-person audience, please raise your hand and wait for the moderator to prompt you before using the nearest microphone, which would be the table mics, to pose your question together with your name and affiliation. Thank you for your cooperation. To kick off the seminar, I would like to invite Ms. Sharon Seah, Senior Fellow and Coordinator of the Climate Change in Southeast Asia program, to give her welcome remarks. Sharon, please.
Thank you. Colleagues, ladies and gentlemen, good morning and a very warm welcome to the IC's Yusof Ishak Institute. And to my fellow collaborators, very warm welcome, and I'm glad that after 3 years we finally meet in person. To those online, selamat pagi and welcome to this hybrid seminar, Peatlands Futures, Integrating Data and Community Governance for Nature-Based Climate and Haze Solutions. Now, 3 years ago when Dr. Helena Varkkey approached me to join this tripartite project involving researchers from 3 countries, Indonesia, Malaysia and Singapore, to investigate these issues concerning peatland carbon emissions and transboundary haze, I immediately said yes. Because in my mind, transboundary haze was an issue of priority for this region. And those of us who have lived here in Southeast Asia for some time would be aware of transboundary haze pollution episodes that we go through. If you are of a certain vintage, you will recall that the most severe episode was in 1997, caused by massive forest fires in Indonesia. But if you are relatively young, the most recent memory you have will be in 2015, when prolonged fires on peatlands was exacerbated by El Nino, which is a weather event that's out of our control. So at the time when we started this project, the academic research was only beginning to connect those dots between intensifying weather events caused by climate change, peatland fires, and transboundary haze. In fact, the entire GHG emissions narrative had not yet been fully accounted for, and the possibility of peatland conservation as nature-based solutions in global climate action was only beginning to be discussed. But later, when the Article 6 of the Paris Agreement was fully negotiated in 2024, the role of carbon markets began to take precedence, began to be better understood, and countries then thought about conservation of peatland ecology as potentially bringing economic benefits to their countries. But without a good understanding of available peatland data sets, the harmonization of standards, and full compliance and enforcement, carbon market integrity will be affected. So through this research for this project, we have now gained a better understanding of how peatlands can play a critical role in global climate mitigation. Our panel today will discuss these factors in greater detail. But what I want to say is thank you very much to Dr. Varkkey for her initiative in gathering a regional group of researchers and community practitioners. And now we can proudly say we have a community of governance practice in understanding these issues better. And this is good news for policymakers. Why? Because it means that communities can now take greater ownership and help to bridge the gaps in data standards and enhance transparency, because these are precisely the problems that have inhibited better haze governance in our region. We are also honored today to have with us a fellow grantee under the Asia Pacific Network for Global Change Research, Dr. Azliyana Azhari from Monash University, Malaysia, to join our panel in presenting her research on media analysis of climate and haze issues as reported in the Malaysian and Indonesian media. The media angle is important in haze governance as well because it is what goes out to inform the public. Finally, I'd like to take this opportunity to thank the Asia Pacific Network for Global Change Research for their strong and consistent support for our twin projects for the past 3 years. With that, let me introduce our guest of honor, who's not able to be with us in person today, to deliver today's opening remarks. Professor Dr. Gusti Anshari is a professor at the Soil Science Department and Environmental Science Postgraduate Studies at Tanjung Pura University, Indonesia. He obtained his PhD in Geography and Environmental Science from Monash University, Australia, and has worked as a tropical peatland researcher for the last 20 years. Pak Gusti is well known and a leading Indonesian academic in the regional peatland study community, and much of his career has been spent on studying peatland resources, hydrology, and sustainable management. So without further ado, I'd like to invite Pak Gusti to deliver his opening remarks. Pak Gusti, please.
Thank you very much, Ms. Sharon Seah. Thank you very kind introduction. So, all right. Good morning, respected participant. I hope you can hear my voice clearly. And also for those who are online and offline, I am very sorry that I couldn't attend physically in this seminar. So, first of all, it is with a great honor that I have a chance to deliver this opening remark. This seminar is a component of the launch of a policy brief titled Evidence-Based Policy Making for Haze and Climate Nature-Based Solution in Southeast Asia Peatlands. As Ms. Seah mentioned, Dr. Helena Varkkey led the RPN project titled Policy Governance Approaches to Cooperative Mitigation of Peatland Carbon Emissions and Transboundary Haze in Southeast Asia. So this project addressed significant concerns regarding peat fires and sustainable peatland management in Indonesia and Malaysia in particular. And also, as you are aware, peatland extent in these two countries is the largest in Southeast Asia, at least encompassing 20 million hectares or more. So we can go back in the early 1970s, we opened this peatland. There was no significant interest in tropical peatland ecosystem at that time, aside from timber extraction from peatland forests. So there was no discussion about peatland carbon also, and the crucial role of tropical peatland in climate mitigation. So in the past, I would say peat fire was considered in quotation as a normal activity. And then as Ms. Sharon Seah already mentioned, in 1997, the region experienced one of its most significant peat fire, exacerbated by the El Nino phenomenon that triggered severe drought. As a result, a haze enveloped the regional skies, leading to transboundary haze pollution. So this haze crossed the Malacca Strait, affecting Kuala Lumpur and also Singapore, and impacting the health of the local population. Since then, the haze has emerged as an international concern and a recurring regional issue as peat fires continue to occur annually, whether with El Nino or La Nina occurrences. So the affected communities by peat fire are not only people in cities, but most importantly, local communities who absolutely deepen upon the health of peatland ecosystem. Currently, the health of peatland ecosystem in Indonesia and Malaysia is not very well, and this leads major issues of international concern such as peat fire, loss of unique biodiversity, carbon emission, and the decline of local communities' livelihood. Respected participants, today we gathered to discuss integrating data and community governance by nature-based solution and haze mitigation. So we have renowned speakers will address this pressing international concern from diverse perspective. So firstly, we have Ms. Azliyana from Monash University, Malaysia, will provide an in-depth analysis of media coverage of peatland haze in Indonesia and Malaysia. Then we have Prof. Matthew Ashfold will elucidate the detrimental impact of human disturbance on tropical peatland in Indonesia and Malaysia, resulting substantial carbon emission that accelerate the climate change. To mitigate these challenges, sustainable management of tropical peatland presents opportunity for development of nature-based solution. The solution hold the potential to establish a novel management model that align with sustainable development goals, I hope. So following this presentation, Professor Alex Lechner from Monash University, Indonesia will address the uncertainties and knowledge gap surrounding peatland data, particularly concerning peatland extents in Indonesia and Malaysia, and uncertainties of greenhouse gas emissions. So this panel discussion will provide valuable insight into the critical issue of peatland management, paving the way of the development of effective strategies to safeguard this vital resource in this region. So, respected participants, this project has spanned 3 years, as Ms. Seah already mentioned. So, during which it has been effectively managed by Dr. Helena Varkkey, the principal investigator from the University of Malaya, has demonstrated exceptional organizational skill and has consistently scheduled fortnightly meeting over the past 3 years. One of the project's significant output is a policy pre-titled evidence-based policy making for haze and climate nature-based solution in Southeast Asia peatland. So Dr. Paki will present recommendation on how to integrate scientific knowledge with community insight and power to establish effective practices for sustainable peatland management. Furthermore, I extend my sincere gratitude for all registered participants, approximately 100 individuals from various countries who attended physically and also online the hybrid seminar. Additionally, I express my gratitude to APN for their support of this project. Thank you for ICS Yusuf Ishak Institute for hosting this seminar. Importantly, I also acknowledge Fatima Tuzara Alkap has been working so hard to assist the project management, and also Nurisa, she is now in Germany. So on behalf of the project team members, I would like to extend our heartfelt appreciation to the local communities in Selangor, Malaysia, and also Limbung, Indonesia, who have been invaluable in sharing their knowledge and expertise on implementing wise practices for peatland management. So finally, thank you very much and wish you all have a useful seminars. So I go back to moderator.
Thank you, Professor Anshari. Now, I would like to invite Sharon and our esteemed panelists to the stage to begin the seminar.
Okay, so I think the introductions have already been made, so we'll just dive right into the topic, and I'll start with Dr. Matthew Ashfold, followed by and okay, Dr. Azliyana, and then Alex. So over to you.
In terms of presenting the slides, how do I do that?
How can we get the slides up? Okay, there you go. Oh, you are free to speak from here or from the rostrum. And the clicker is next to you.
Okay, wonderful. Okay, I think everyone can hear me fine now. Right, so yeah, good morning, everyone. It's very nice to be here, and as the kind of introductory remarks have made clear, it's a great pleasure to be at this event at the end of our project over the last 3 years, and to share some of the outcomes from our project, and I think likewise as for your project as well. So I have the task this morning of, I think, trying to lay the foundations for the subsequent talks, to try and provide, as the title says, an introduction to some of the really important dimensions of this, I think, crucial issue for our region, okay, the sustainability of these peatland landscapes. And so, yeah, you can see on the slide, I have 5 bullet points. So these are the topics I want to introduce quite briefly. I'd like to highlight the kind of the critical importance of peatlands in Southeast Asia from a number of different dimensions. Briefly highlight some of the anthropogenic pressures on peatlands over the past decades and ongoing. A little bit more on this key regional issue of fires and haze, air pollution. Then touching on carbon emissions and links to climate. And then finally, this topic of nature-based solutions, and clearly, particularly involving peatlands. And so within the slides, I'm drawing on a number of different resources, but I think these two are worth mentioning. There's a report, Global Peatlands Assessment, coming from the United Nations Environment Programme. Obviously, this has a global perspective, although there are regional sections. The second publication, so this is published through ICIS. This is one of the outputs from our project published last year, and this is focusing more on the Southeast Asian region. And so, yeah, the slides I present will draw on some of the information from these reports and some other sources. Okay, so peatlands in Southeast Asia. Globally, it's estimated that peatlands cover around 3 to 4% of the land surface, and there's an important, I think, commonly stated fact. Peatlands are estimated to store twice the amount of carbon as found in Earth's forest biomass. So this reflects their long-term role as a carbon sink, so accumulating carbon in the typical waterlogged conditions in the soil over thousands of years. The second point, Southeast Asia. So here the number, again, this is a number taken from the UNEP report. It says 24 million hectares. You may have noticed in Pat Gusti's remarks, I think he mentioned 20 million hectares. Okay, so there are, I think we are not completely confident what that number is. This is an important point that I think Professor Lechner's presentation later will pick up on. But it's clear that in terms of the tropics, Southeast Asia is important. There is a substantial amount of peatland in our region. And the third point on the slide, particularly in Indonesia and Malaysia, very, very roughly, around 10% of the land area in both these countries is thought to be peatland. The final point, peatlands, or particularly in Southeast Asia, typically these are tropical peat swamp forests. So it says, the slide says, these store tens of billions of tons of carbon. We can try and put that number into perspective. So how big is tens of billions of tons? So I understand that Singapore's national annual greenhouse gas emissions are something like 60 million tons of carbon dioxide, okay? And if we only take the carbon part of the carbon dioxide, it's maybe more like 15 or 20 million tons of carbon. So we're talking about kind of 1,000 times as much carbon or more in these peatlands than Singapore is emitting every year. Not only carbon, these peat swamp forests are special for many reasons. The UNEP report suggests that in Southeast Asia, these peatlands contain some of the highest biodiversity in the world, and very importantly, there are people living in these areas, and so these landscapes support the well-being of peatland communities. And I think it's these multiple dimensions that make this such an intriguing and challenging topic. It's clearly very important, but there's so much complexity, and I think through this project we have managed to make some advances. So not only statistics, I wanted to also include some photographs. So these are photos taken during our project. On the left and on the right, these are photographs taken in Limbung in Indonesia. So this is in near Pak Gusti's base in Pontianak in West Kalimantan province. And then the picture in the middle, this was taken in Malaysia. This is in Kuala Selangor. This is just to the northwest of Kuala Lumpur. And so in these pictures, we can see the important, some of the important features of peatlands illustrated, not least the water, okay, this distinctive waterlogged property of natural peatland systems. But we can also see the people and agricultural systems intersecting with these landscapes. And so we know also that in our region, the peatlands have been pressured. They have been changed over decades. Okay, so the first bullet point here says that large areas, and again, I've intentionally not put a number on this because I think Alex will talk more about some of the uncertainties in quantifying, but large areas of peatlands in Indonesia, in Malaysia, have been changed in different ways, so drained to make the soils potentially more available for agriculture, also a loss of forests. The second point mentions oil palm. So oil palm is certainly not the only reason that peatlands would have been changed over the years, but it's an important one. And again, Alex will, I think, talk more about some of the role, or some of the data we have describing how oil palm and peatlands intersect. The third point touches on some of the environmental consequences when we change the peatland systems. So clearly, by nature, drainage is like a hydrological disruption. When the water is partly removed, the peat soils can subside. This is kind of representing a loss of material, a loss of carbon from these systems, and resulting in CO2 emissions to the atmosphere and fires as well. So as the peat soils are dried out, they can become very prone to fires and a rich source of flammable material. The final point suggests that formerly relatively small areas, again, I've not quantified on purpose, of Southeast Asian peatland is protected. The map I show at the bottom of the slide, this is one example of one of the analyses from our the book we've published with ICES, the orange book. I think most people in the room will have a copy of that with you. This is just an example of where we have mapped a data set about canal density, which is obviously a good indicator of drainage, and where does this exist in peatland areas. And yeah, a large fraction of the peatlands can be seen to be under some kind of drainage. Okay, so moving on, we've already heard a number of times about fires and haze. And the fires that we experience in the region, the resultant haze air pollution, not only coming from peatlands, but peatlands are an important location, especially the drained or degraded peatlands will be very prone to fire. And those fires occurring in peatland will be particularly productive in terms of their the production of particulate matter, air pollution, and carbon dioxide emissions. Okay, so the peatland fires can have a big impact in terms of the emissions of these air pollution and greenhouse gases. There are estimates of the costs of these fire episodes and haze episodes. The one mentioned on the slide by the World Bank, Sharon mentioned the 2015 haze. This was a really substantial event around the region. And there are estimates of very substantial costs. But of course, it's a complex business to do this kind of estimate. I think, for example, this World Bank estimate, they suggest they have not included the long-term impacts on health. And so exactly what's included in these calculations will certainly affect the costs. The third point, so climate variability. So this is making the point that the fires are kind of the result of human activity and climate conditions, okay? And different climate states can be more or less conducive to fires starting and spreading and being maintained. ENSO, this is the El Nino Southern Oscillation, is mentioned on the slide. This is a very prominent form of kind of natural climate variation. And when we have a dry phase of this oscillation, an El Nino event, certainly we can have large-scale fires in the region, but for sure we can have fire and haze in other kinds of dry condition not associated with El Nino. As well as climate variability year to year, we should also think about climate change in the longer term. And as climate changes globally, what would be the impacts on weather conditions that promote fires in the region? So will we have longer hot, dry conditions, longer spells of hot, dry conditions with climate change? This is a very important question. Finally, there has been long-standing effort to try and address haze as a problem in the region, not least at the ASEAN level. But I think the effort continues to try and address this problem. There are complexities around governance scales from kind of regional politics in ASEAN down to the kind of the community scale where the fires are actually happening. And we've already, I think Sharon has mentioned or alluded to issues around data and understanding where fires are happening, who owns that land, understanding how much air pollution is there, different ways of quantifying air pollution in different countries. These have all, I think, presented a challenge to trying to tackle this issue of haze. Next, I want to talk about more on the carbon emissions. So this is the climate mitigation dimension. So peatlands are a very substantial source of greenhouse gas emissions. And maybe there are two main categories of those emissions, illustrated in the graph on the right of the slide. Okay, so the graph on the right is presenting Indonesia's reported greenhouse gas emissions. I think, if I can read that correctly, starting in the year 2000 up to around the year 2020. And so I think this is actually not the Indonesians' latest reported emissions data. This is from a nice publication from 2023, so I think it's the previous iteration of the reported data. But it still serves to illustrate nicely the importance of peatlands. And so the size of the bars each year, these represent the size of the emissions, and there are different contributing sectors. And what we see is the contributing sectors, peatland is very important. The dark blue parts of the bars, these are peatland fires, and these clearly vary a lot year to year. Okay, some years being very, very large, some years smaller. The brown parts of the bars, this is broadly, I think, the forestry and land use sector, but a big term in that sector is the peatland oxidation or decomposition. So this is the gradual conversion of drained peatland carbon into CO2 in the atmosphere. And this is a more continual process. But both are big numbers, the fires and the oxidation. And so the graph is for Indonesia. If we look at the data that Malaysia reports, peatland, especially oxidation, is a big part of the greenhouse gas emissions as well. But it's not only governments reporting greenhouse gas emissions data. There are multiple academic studies trying to quantify emissions due to different kinds of peatland process. And they don't always agree. They can disagree quite substantially. And so there is uncertainty about the size of these emissions. It's pretty clear they're big, but the exact numbers are difficult at the national scale. And so more and more transparency and explanation of the methodologies underlying the quantification is helpful. And so this is the final substantial slide I have, and this is introducing this concept of nature-based solutions, and particularly those involving peatlands. The first list of bullet points, it says UNEP, this is the UNEP peatland assessment. They indicate that peatland and nature-based solutions can contribute to biodiversity outcomes, climate change adaptation and resilience, as well as the mitigating or the reducing the emissions side of climate change. They highlight the potential for these nature-based solutions to contribute to the livelihoods of communities living in these landscapes. Additionally, in Southeast Asia, reduced risk of fire is a very substantial additional benefit of potentially of a nature-based solution in peatlands. In terms of the MBS categories related to peatlands, so we could potentially envisage restoration projects, okay, to particularly involving re-wetting. We can have improved management of peat-based agriculture, and also protection of peatlands as well. And so there have been a number of studies looking at the outlook for these kinds of nature-based solution. Often they are indicated to be high potential, so this is like very substantial positive outcomes in terms of some of these dimensions, and potentially cost-effective as well. But of course, again, the way the quantification of the cost is done would be very important, and the different type of project may have different kinds of costs. And so, as Sharon has kind of indicated in her remarks, there's more and more interest in these kinds of projects, okay, potentially being linked to carbon markets and carbon credits as well. And so given the apparently very high potential, it's very much worth thinking about some of the challenges in governance and economics. Okay, so that was all I wanted to do. Again, it's just trying to set the scene for some of the upcoming talks, trying to review some of these important topics for peatlands. I started with the importance of peatlands in Southeast Asia, some of the anthropogenic pressures on those peatlands, the key topics of fires and haze air pollution, carbon emissions, climate, and then highlighting this topic of nature-based solutions. And so we've already heard what will be next in the seminar, so I won't repeat that. And so maybe just to finish, I'd like to acknowledge the team. Thank you for listening, and also acknowledge the support from the APN. Okay, Sharon.
Thank you. Thank you very much, Matthew. I think that was a very good scene setter for the discussion that we will have later. And now I want to move on to Dr. Azliyana for her presentation. Can we have the slides up on the projector? I think you can just go ahead. Can I?
Okay. All right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to everyone. First of all, I would like to thank Dr. Helena Varkkey for graciously inviting our APN project to be part of this conversation. It's really exciting to also share the findings from so the APN project that we are working on is a capacity building project. This is the team. You have seen that Prof. Lechner is in both of the teams. So one of the first thing that we did when we applied for this project a year after Dr. Helena's project was Prof. Lechner was saying that, oh, I'm in another project led by and maybe we could do something together towards the end of this, and this is where it is. So it's pretty exciting to be here. Thank you so much for inviting me and for letting me share haze and climate change in media and public discourse, comparing Indonesia and Malaysia. So for context, Malaysia and Indonesia is experiencing significant impact of climate change, including rise of temperature, extreme weather events, impact on public health, reduced crops, yield, which impact food security. But public awareness of climate change in Malaysia and Indonesia specifically is quite limited. They are aware that climate change is happening, but there is lack of participation in discussion on climate change and adaptation and mitigation. So despite the realities that it's happening around us as we speak now, Malaysia is being hit by flood in certain regions already in late November. It is monsoonal, but with the climate impacts, the flood impacts are getting really extreme, with places that has never been affected by floods is now facing really bad floods and those kind of things. So that's the public involvement in addressing climate change in Malaysia and Indonesia is quite limited. Lack of participation and would say lack of push from the bottom up for policy changes in issues related to extreme impacts of climate. And at the same time, Malaysia and Indonesia are globally hotspots of climate change challenges, with the position of the two countries. Climate change threatens decades of development gains, and the impacts fall most heavily on vulnerable communities such as rural population, indigenous groups, and those with limited access to health services or resilient infrastructure. So in order to help these communities, we first have to understand these vulnerabilities to help guide for more equitable climate policies. And at the same time, both Indonesia and Malaysia has also made strong commitments toward climate action, and through national policies, emission targets, and involvement in regional frameworks such as ASEAN climate agreements. But effective implementation requires cross-sectoral collaborations and clearer communication. So this is a slide that show deeper carbon, a little bit deeper of the carbon dioxide emission context. It shows the per capita carbon dioxide emission, including land use. What it tells us is while Indonesia emits a large total volume of carbon, its per capita emissions are relatively low compared to more industrial countries. Malaysia, on the other hand, has higher per capita emissions, reflecting a more energy-intensive lifestyle and industrial economy. As a low middle-income country with large rural population, climate change could push vulnerable community back into poverty with this current condition. So this is also a little bit from what I've already mentioned earlier, how climate change threatens the advances in human development and poverty reduction made in Indonesia and Malaysia. So this is some of the media reports that shows how Indonesia and Malaysia have made strong commitments in tackling climate change. I'm not gonna touch too much on why peatland matter, because I think Matt has covered this quite extensively. So the map shows where peatland and distribution, focusing in Malaysia and Indonesia. I will go next into the output of the output of our APN funded project, where we did a media analysis overview of how often climate change and different extreme weather events are reported in Malaysia and Indonesia media. So Haze is one of the extreme weather events that we look at. We also look at floods, landslides, heat waves, and I can't remember the other one, sorry. So this is to understand the public discourse of how haze and climate change was interpreted in the past 10 years, from 2015 to 2024. In total, in Malaysia media, there's almost 2,300 mentions of haze and climate change. In Indonesia media, we only focus on Bahasa Indonesia. There's 727 mentions. Sorry, I can't speak this morning. So the peaks of mention in media generally coincide with severe haze years, dry seasons, and policy and political events. Going a little bit deeper in year-by-year analysis of the reports, how often climate change and haze are reported in the media in Indonesia and Malaysia. So when we were doing this media analysis, the search terms that we use are haze and climate change. So if it only mentioned haze, it's not recorded as one of the numbers. So we wanted to see how it's connected, whether or not the media is making connections between climate and haze and climate and the other extreme weather events. So in the 10 years that we see how the media is reporting climate change and haze in Malaysia and Indonesia. In 2019, there's also a haze event, and in 2023, I believe there's communication between both governments about haze that spikes the number of reports it happens to be the highest number of reports in Indonesia, Bahasa Indonesia. This results suggest that haze in Malaysia specifically is heavily localized in Bahasa Malaysia reporting. In English, it's framed more episodically. So in terms, one of the things that climate communication, in communication studies, to design effective communication, we need to understand our audience. So we also did background demography and how surveys and media consumptions. This is actually one of the projects that I started working on when I start with the Monash Climate Change Communications Research Hub. It's a long name for a hub trying to research climate communications, but so we launched a survey, and the results from this survey is what led to the application of this grant for capacity building in reporting climate change in news. So we try to understand first the population, understanding the audience who we're working with. So Indonesia and Malaysia, we have very different number of population, and but the density of people per kilometer is not too different because Malaysia, being a very small country, have quite a big number of population. When we were doing this project, we also compared with Australia because Australia is also a partner in this project. So Australian population is similar with Malaysia, but with much bigger land mass. So their population density is a lot smaller compared to Malaysia. One of the other things that we look at is ethnicities, religions, and language. Being multi-ethnic countries with different ethnic groups, we all speak very different languages, and we have different beliefs that shapes our narratives of the environment and our beliefs. That added to the layers of complexity when we try to communicate a certain issue. We have a similar age median rate at 30 and 32 years old, high literacy rate, and high, especially in Malaysia, we have very high urbanization rate, and poverty rate at 9.5 for Indonesia and 5.6 in Malaysia. And like I mentioned, language-wise, Bahasa Indonesia is the main language in Indonesia, but there are more than thousands of different dialects that are spoken to. And although most speaks, like in Malaysia, there's 4 main languages, but most communications and most informations on climate and haze that comes are in English specifically. So that's already set apart the information availability to to the people who doesn't actually really speak the language. And we also look at media consumption because we wanted to treat attention economy as in the audience attention as something that is limited. So we look at where their attention is already are, so that the information should be channeled to their attention economy. So where they are already giving attention, that's where we communicate the information. So both Malaysia and Indonesia media preferences are online, social media, chat apps, and online news portal. But in Indonesia, television remains a popular medium, especially in older generations and regional cities. Compared to in Malaysia, only 52% who are still relying on TV news for information. In the survey, we also look in trust, how Malaysians trusting the information about climate change. And 87% said they trust scientists and environmental groups, which is good because they want the information from scientists like we all. But there's the gap between the information from scientists that reaches the public, because most of our publications are stuck behind paywalls and are written in languages that is not meant for lay consumption. So that is the spark for this project that we are looking at. We also look at socio-political perspective, because that's also how, like I said, how that shapes the belief and of the information that are given to them. So we explore in the audience context. It's deeply influenced by socio-political environment in which people live and engage with information. We also look at the audience characteristics. For Indonesia, we refer to the percent perubahan iklim that is reported by Development Dialogue Asia and Change for Climate Center. It is not directly comparable to Western segmentation models, but they use similar questions around level of concern and awareness, and they produce like 5 distinct segments. The large 33% are the established and informed conventionals. They are mostly urban upper middle classes individuals who are knowledgeable about climate change, and they actively engage with the issue and often see it as part of broader societal or developmental conversation. Then we also have the pacifist cheerleaders at 28%. These are mostly the middle income earners with strong digital presence. They are active on social media and might frequently share content, but they are sharing for the sake of sharing, but not engaging deeply with what they share. They are digitally visible, but in need of more sustained, meaningful involvement. And then there's the 27% of defenders of their land. That includes group of agricultural workers and housewives. They may have lower levels of formal knowledge, but they're often highly motivated because it's their bread, because they are earning from the environment. So their motivation comes directly from the direct live experience. The smaller group are the apathetic young people, which roughly are the 5% of population that are younger and show little concern or urgency about climate. And then there's also 8% of overwhelmed traditional village people, and because they, due to lack of access, lack of digital tool and media coverage, communications with this group need to be highly localized, visual, and community-led information. While in Malaysia, we run the survey. It's an online survey based on our own survey. We use the 6 America Super Short Survey tool and we found that 8 in 10 Malaysian are at least alarmed and concerned about climate change that is happening around them, and 17% are cautious, while only a very small number, that's about 3% that are disengaged, doubtful, and dismissive. But these segments, yes, they are alarmed and concerned, but it doesn't reflect in their climate-friendly behaviors due to multiple reasons. So it's very interesting to see that although the awareness level is high, but the conversion into behavior, it needs a lot of work in conversion in behavior. So as mentioned earlier, so this is the 5 topics that we look at in the media analysis: landslide, cyclones, flood, wildfire, drought, and haze. So because both countries are highly vulnerable to the impacts of climate change due to the different combination of geographic exposure, socioeconomic inequalities, and dependence on natural ecosystems. During the second phase of the project, we run focus group discussion in Malaysia and Indonesia. I think you were there in one of our focus groups. So these are the themes that came out in what are the needs and what are the challenges in for the media reports to report climate change related news. The themes that came out are training, visualizing, personalizing. Personalizing and localizing is something that comes out very often in the need of getting the information localized and personalized. As we all know that the poster mascot of climate change is polar bears, but when we show the picture of a polar bear losing ice caps, it's not something that it feels distant. It feels like it's a distant problem. It doesn't feel like it is our problem compared to different, much localized impacts. But the connection between climate and localized impacts are not as distinct as the connection with climate and the polar bears losing their homes. So those are the things that needs a little bit more work on, and we're working on hoping to publish, to submit this as a publication soon. There's also a lot of conversation around how news around climate change is deflating. It feels like it's doomsday all the time, so people tend to avoid it. There's also censoring by different parties, clearly due to conflict of interest, and sensationalizing certain news. So those are the things that, the themes that we look at, and hopefully we can discuss a little bit in a little bit deeper. As also part of the outcome on how to build public understanding in what we are talking about. So one of the things that I've mentioned a lot earlier on, knowing your audience, how their demographic disposition and knowledge, to then only you get to tailor those messages in the information that they would be interested to be reading and interested to understand. Significant and relevance to your audience, include information of how science came to know the fact on your topic, know that the effect that you wish to have with your audience. In this case, behavioral change, long-term behavioral change is something that we are aiming for, and ensure your communication platform is appropriate for your audience. That's why we look into which communication platform they're looking at, and also use of language suitable to your audience. I would like to end the slides with some of our outputs. So in the proposal, we promised that we are going to build a resource bank for climate change reporting, resources in climate change reporting. So what we aim to do is to group together all the relevant resources that journalists could potentially use in climate change reporting. So this is some of the examples for global resources. And we also have some Malaysia and Indonesia specific resources. Through developing this, we actually, and one of your projects is also listed in the in our resource bank so when you click on bite-sized climate action, it leads to the website. One of the things that we realize that is not available is glossary of terms in that are familiar, glossary of terms in climate change reporting that are in local languages, and that's probably something that we would like to do in future projects, because, like I said, we need more information in local language so that it reaches a lot more people. Thank you so much.
Thank you so much. That was so rich. And when you talked about the different terms, it reminded me of, because we do a survey every year. It's a regional public survey. And the first year, we had asked a question on NDCs, which stands for Nationally Determined Contributions, which obviously was lost on the public because they had no idea how to connect that. So it taught us a lesson about using terminology that was more relatable to the public when you're doing this kinds of survey. The other takeaway I have from you is, hey, as academics, I think we need social media, more social media presence and an outreach. But it's pretty difficult, right, to distill all of your wonderful research into a few sound bites. But it does show that there is that market that wants to consume, but they have no time or no patience to consume long journal articles. So perhaps that's one way. But let's go and talk about that later in greater depth with our audience. And our last presenter is Dr. Alex Lechner.
Thank you so much, Sharon, and thanks so much to the previous speakers. So I think it was a really lovely setup in terms of why peatlands are critically important in terms of our previous speakers, and then also that element of needing to communicate this challenge of peatlands important, we need to do something, and we need to communicate that through the media. But one of the huge challenges for things like peatlands which account for 5% of global emissions, our Southeast Asian peatlands, which are responsible for 5% of global terrestrial carbon, hugely important for human development, is that we still don't quite understand them well. We still don't have exact numbers around simple figures such as the total area of peatlands. They vary depending on who's doing the mapping, which government body, is that academia. And you've probably heard debates around, different countries saying oil palms, your forests as well. So let's include oil palm as part of our forest count. So there's huge simple uncertainty in terms of the practical computational challenge of saying, we can't map things for sure, but then there's sort of semantic uncertainty in what are we categorizing as peatlands. And then, of course, imagine all the other forms of data that we need to integrate with the peatland maps to actually manage them. Where are the fire hotspots happening? Where are canals being created and peatlands being dried up? Where are the communities who are depending on these peatland areas. So there's this real huge challenge around that. And that's what this part of our Peatlands project aimed to just start touching on this, the surface of this challenge around what are the various forms of uncertainty in our understanding of peatlands, which makes us then reflect, okay, how do we communicate that? For example, you know, the media are after nice sound bites, simple messages around peatlands, and Az and I, we always have these discussions about, you know, oh, the science is quite difficult, yet, you know, around, you know, peatlands, what we need to do to, you know, better manage peatlands, for example. So this presentation hopefully will not be too painfully technical, but because my background is landscape ecology, remote sensing and GIS, and we're at ICS. So I imagine the audience is perhaps, you know, examining these issues from a very different perspective. But I think it's these interdisciplinary challenges, this connecting, you know, scientists with communication specialists, with community, social scientists and so on, that's a really important challenge, and one of the challenge of our age, because we know all of these sustainability challenges are very interdisciplinary, and without looking at the complete system, we're never going to solve them. So for this project, this is the background to the project. So we were assessing these challenges of mapping and quantifying peatland extents, dynamics, impacts and emissions, and explore the implications for data uncertainty. So we did this systematically. We did a literature review, as well as bringing 22 peatland experts from Indonesia, from Malaysia, and also from Singapore. I think there was an NUS person included in that panel. And this is a picture from at Monash University in Indonesia, in Jakarta, in August. So we brought all these experts together. And in parallel, we did some mapping just to start getting an idea around the types, the range of uncertainty. So when I mean uncertainty, I mean the various forms of uncertainty, you know, so how many hectares are peatlands, for example? You know, we know there are a lot of them, but exactly how much, for example. So that's what we're trying to get at, that uncertainty, and how does it manifest itself? We asked ourselves and also the experts a range of questions around the themes of peatland data needs, mapping peatland and its condition, calculating greenhouse gas emissions from peatlands, and then thinking about, you know, the environment, you know, the challenge, the cross-cutting challenges and opportunities for enhancing peatland data, and also thinking about things like governance and so on. Who are the people who are putting these data sets together, and how can they be better advised in terms of mapping more accurately, perhaps, or perhaps recognising this uncertainty. So we asked a range of questions to our panellists and to ourselves. But before I go too deeply, I'll try to give some background in terms of the more broadly, what are we mapping and what are we measuring? So, of course, we're doing lots of MRV, measurement, reporting and validation for various levels. So you can imagine if we're doing RSPO reporting, the roundtable on sustainable palm oil, you know, to certify palm oil that it's to certify palm oil, we'll need a whole host of like remote sensing and fieldwork data to demonstrate, for example, that deforestation hasn't occurred recently in palm oil. At the other end of the spectrum, we need to map our peatlands and all of our forests, but we need to map our peatlands for our reporting to the UNFCCC under the Paris Agreement to say this is how much forest was lost and this is how much the emissions were. So there's a range of ways in which peatlands, and mapping and measuring and reporting and validating peatlands are the heart of a range of different kinds of environmental challenges, and as well as reporting challenges both at the local scale, if we think about communities, if we think about, for example, carbon offsetting, where companies are coming into areas and claiming that peatlands have been restored, and we've measured this and we can tell you this is how many CO2s have been captured. We're using mapping and measuring technologies to do all of that. So it's really a vast scale, from local applications to national reporting for climate change, where this kind of uncertainty in our data have huge implications. And generally what it is, it's a combination these days of, you can see that diagram, we have satellites and drones, so this is remote sensing, and then at the other, and that's often connected with the field work on the ground. So it's a combination of remote sensing and this field data, which underpins all this measurement and reporting, but also has all this uncertainty that's rarely reported, and probably not many people realise just the sheer magnitude of this uncertainty. So if you imagine, those are the types of systems and reasons why we're doing this kind of mapping and measuring, but there are a range of components of the peatland system which we have to understand in order to better manage it, in order to conserve it. So we have the biophysical functions, so things like hydrology, the biodiversity, the nature of biodiversity, the structure and the function of these forests, the total amount of carbon within these peatland areas. So there's a whole host of complex things. Some things like whether there's a forest or there's no forest is much easier than, for example, measuring the height of the water table. So that's really critical to understand how wet peatlands are, and therefore the likelihood of a peatland burning. So things like whether peatland is there or not is, you can imagine, you can see that from space, much harder to measure the water table. So you're more likely to use proxies and some hydrological modelling, and you can imagine the easiest thing to do is just say, how much peatland there is, the extent, but much harder, for example, to measure these much more complex things like hydrology, which of course is critical for understanding things like haze and so forth. So we need to map the biophysical functions of these peatland forests, communities, and the biodiversity that's there, important for greenhouse gas measurements, emissions and offsetting, and of course for biodiversity conservation. But we also need to map the impacts. For example, Matt showed this great picture of a map of drainage canals across Southeast Asia or Indonesia. So we need to map these impacts. We need to be able to map clearance and deforestation. So we want to be able to map extents, but we also want to say some areas have perhaps been logged slightly, some areas perhaps we've had intrusion, well, intrusion's a strong word, but is perhaps more overutilised by the communities, so slightly more disturbed. We want to be able to map the fire, air pollution and so on. So there's a whole host of other impacts we'd also like to, or we have to map as well beyond the peatland extents. And then we want to think about what are the management approaches being used, and we also would like to be able to characterise that as well. The problem is, and this problem is not just for mapping peatlands, it's a problem of all science, is this idea that we have, real world phenomena, be it peatlands and the peatland condition, be it we're characterising the nature of urbanisation or any other kind of modelling application. Is we have the real world phenomena, we tried to abstract it, we tried to say we're going to measure these variables. We then have some sort of technique, some remote sensing, some field technique, and then we end up with a physical representation of what we claim we are mapping, be it peatland extent, be it the water table height, be it peatland condition. And then we have that physical representation that we have modelled. Of course, commonly, all you ever hear is people say, there are this many million hectares of peatland. No one's saying plus or minus, X, which, as probably most of you would have done in your undergraduate science or maths, or maybe even high school maths, you would have been aware about things like error bars, and standard deviation in terms of your estimate. So that's the most simplest form of uncertainty or accuracy. But of course, we never really see that when we're talking about many of these phenomena. And I'm equally as guilty. All of us scientists are equally as guilty because it's very hard to do. So then you have this, layer that describes peatlands or fire intensity or condition or whatever, and then we put that through analysis. And then, of course, that analysis has errors. You're combining peatlands with oil palm extent, with water table, so then they magnify, and we don't know what happens to the errors in all of these layers when they're put together in terms of they may multiply, it may be additions or so on. So, and so this is what we're finally using, this combination of, maybe field data plus remote sensing data, and then we're making estimates, and then we're doing management, and then we're hoping to address global challenges like climate change, yet we know there's a host of uncertainty associated with that. So, as a starting point, one of the most basic things we imagine that we could do is just get an estimate around how much peatland there is, because those numbers get thrown around a lot. And so each of these rows indicate a different peatland data set, and perhaps focus on these numbers in bold, and they basically indicate, the different estimates that are out there for the million hectares of peatland. And of course, there's real change between the numbers. For example, Page is a 2011 data set, while the UNEP is a 2022 data set. So you imagine there might be some change over time because forest is lost. There's also differences associated with peatland definition. Some are talking about they have different semantics around what is classified as peatland. But in the end, people like myself and many people will just take that raw number and go, this is how much peatland there are. And I think Indonesia is perhaps the easiest to see. So you can see for Indonesia, we have estimates ranging from Anda et al. Has 13.4 million hectares, all the way to Gumbridge with 22.54 hectares, and maybe one that's often used a lot is the UNEP version, which is around 20.9 million hectares. So you can see a vast difference in terms of total extent that are characterised by in terms of what's out there. And this is not because people are silly, it's because it's very hard. It's a super challenge, and neither one is correct or incorrect. They all have their own uncertainty associated with their methods. Just as example, if we take, so that's the uncertainty in extent. That's just the total estimate of how much peatland is there. But if we want to ask where the peatland is, which is also a really important question if we want to know which communities, which estates are perhaps not so responsible. For example, there are a range of questions where the where really matters. So if we just overlay two different data sets of Map Peatland, one Gumbridge and one is the Global Forest Watch Zoo et al. Data set, we can see, if you look on the right for that graph, you can see for Malaysia, there's only 19% of those two data sets which overlap, which there are agreements. So those data sets only agree 19% of the time for Malaysia, and for Indonesia, they only agree 25% of the time. So it's not that we have small uncertainties, we have quite massive uncertainties. And I'm not saying this means all the science that comes from this data is wrong. It's still fantastic and useful, but rarely do we reflect on, the uncertainties in all these data sets that we're using. To zoom into the uncertainties around location, in this diagram here, we've combined three different layers, Gumbridge, Zoo, and the UNEP layer. And what you can see, maybe if you have a look at the panel C, you can see that each different layer has very different ways in which they represent data. So, for example, you can see in the light blue, which is only UNEP. So UNEP kind of overestimates, and you can see by the square pixels, it's a very coarse data set. Well, if you look at the purple, which is part of the Zoo layer, which is where Zoo overlaps with this overextended UNEP data set, you can see that's a vector data set, and it's and it creates big blobs of peatland. And then finally, we can see with the, I think it's I may have got these wrong. So the B, A and C, which is Gumbridge, that data set is really fine scale and is based on pixel type mapping. So you can see each of these data sets in the metadata, the way they describe the data, it's probably completely correct, but they've used different assumptions, methods, and so on, and they'll have different representations. Remember at the start, the abstraction of real-world phenomena. So we have this challenge around that, and this is a challenge we need to be aware of. So if you imagine we have just peatlands themselves, and then we want to look at, the impact locations and start overlaying it with other data sets. So this is the example of the various oil palm data sets that exist. So perhaps one of the easiest things to do is look at a single year and maybe have a look. My eyesight's not that good. Maybe 2018. So if you look at 2018 and just go, so the y-axis is just the area estimate, the x-axis is the year. If you just look at the y-axis, so these are the difference in 2018 between each of these dots represents a different data set. The ones with lines are data sets that have time series. But basically you can see if you just compare vertically, you see very vastly different estimates around total area of oil palm. So, when we try, one of the simplest kinds of analyses we're trying to do is let's look at where oil palm is impacting on peatland. So you imagine peatland has problems, oil palm has problems, so let's put the two together, and of course we're going to get more challenges in terms of our uncertainty. And again, it's not to say that the conclusions drawn are wrong, it's just there is a challenge. So you imagine this diagram is just to reinforce, we have the underpinnings of all our peatland work and mapping peatlands extents. We then want to map peatland impacts, which are things like oil palm. And then finally, of course, very importantly, as you heard, peatland's critical for climate change. and climate change mitigation. And then we put all of these together, plus field work, and then we end up with our estimates of peatland greenhouse gas emissions. So you can imagine there is a host of challenges. Here's just an example of where we've just got 2 peatland data sets, 2 oil palm data sets, and what we're trying to do is map what's the area of agreement between all the different combinations of those 2 peatland and those 2 oil palm data sets. And if all of them were exactly the same, the bars, the first 4 bars would be exactly the same height in terms of area estimate. And you can see, there's, vast differences depending on the data sets we put together and use. If we think about greenhouse gas emissions, what generally happens is for the most simplest estimates is we calculate the total area of peatlands. In some cases, we may have a condition estimate, really high condition peatland has a certain greenhouse gas sequestration, low condition may have a lower level. So we basically multiply that peatland extent times a emission factor, and this allows us to calculate what are the emissions coming from the clearance from a deforestation event. And I won't go into all the details of this diagram because this is Matt's area, Matt's diagram. But basically what it shows is that there's the dashed lines show the different emission factors that are most likely used. And what we can see is the same area of peatland can have vastly different calculations of the total amount of greenhouse gas emissions. And some of that could be correct because maybe these are really high quality peatlands, and some of it could be just an artefact of the way in which peatlands have been calculated. So I'm coming to the end. So at the moment, the business as usual is on the left, is that at the moment, everyone, including myself, we look at data, we say, is it fit for use? Oh, I think this data is good or bad. We may zoom into pixels and compare it to aerial data or some sort of ground truth. And if it's fit for use, we'll use it. If it's not, we'll find another data set or make another data set. And then we do all our analyses. And commonly what happens is that sort of inaccuracy or uncertainty is completely lost and ignored for any further use of the data. So what really needs to happen is we need a more complex approach where we're looking at the data, we are looking at the uncertainty within that data. We're calculating uncertainty, accuracy. We're including, there's an extra level of complexity, data at different scales. We'll have different estimates. We want to test uncertainty propagation when we analyse that data. And then we say, is the output of the analysis using that data fit for use, rather than just looking at the input and then ignoring it. So the key is that we would have this quantification, and the final output, let's say it's a mapping output, we'd have the output plus we would have some kind of estimate around uncertainty. So I'm getting to the end. So we've made a series of recommendations in the policy brief that's part that we're announcing here, and we have a longer form paper as well that's coming out. So these recommendations range around the key areas where we need to perhaps increase our transparency, increase our accuracy. So first of all, our peatland extents need to be mapped better, and the uncertainties need to be quantified. We need to be able to map the conditions of the peatlands, the structure, the hydrology, the condition, so on. We need to be able to map the biodiversity within those areas, and we need to map the carbon and greenhouse gas emissions better. And for all of these key challenges, there's a range of more field work, for example, is especially required for things like hydrology and condition and greenhouse gas emissions. But in general, we need to just do a better job in terms of improving the data quality and quantifying the uncertainty in the data, and also being a bit more transparent. Some of the data sets that we were looking at, we couldn't download. They only exist in government, and then they provided as part of their estimates for the national inventory on emissions, but we can't actually look at those data sets and see the uncertainty. The other three recommendations perhaps are a bit more about, the context in which these data sets are being used, and the way we could utilize the data sets better, and also other ways in which we can get better at mapping. And one would be around, so in terms of these challenges, they're land use management and community engagement, spatial data quality and transparency and open data, and then policy and regulatory needs. So they range from including communities, as you'll hear in Helena's presentation, as part of the process, and formal recognition of uncertainty, quality metrics and so forth, from the government, from all these regulatory bodies like RSPO, all the way to nationally. And so just to summarise, so hopefully this doesn't put you off the idea that, everything's wrong. That's not true at all. We're constantly iterating in science, and that's the nature of science. Hopefully we're always becoming more accurate, and perhaps for this kind of research, we're at the stage, and for its application, for example, for NDCs and so on, we're at the stage of where we need to just get better at what we're doing. We need to have more transparency. And sadly, Southeast Asia is so important. I bet there's probably more research done in some tiny little peatland in the UK or something, which doesn't have this great impact, while the forests of Borneo, which are super critical, just has so much less research. So I think we also need to target research where it really matters globally. So we need to do things around improving the quality of mapping, expanding field and remote sensing data. We need to bring the various kinds of activities like carbon and biodiversity assessments. We need more community involvement, and we need to build multi-scale, multi-source MRV systems for all the different ways in which we use this data for managing peatland. And finally, I think, of course, we need to recognise the broader sustainability benefits. If we think about nature-based solutions, there's a whole host of complexity around the co-benefits of nature that need measurement too, and that need to be included to really value peatlands. So just like to thank, this is a fantastic team effort. And also would like to thank the APN as well for their funding. And then finally, a special thanks to all the workshop participants, who were many who contributed to the workshop, and also some are contributing to co-authoring this paper. So thank you very much.
That was fantastic, Alex. Yeah. Yeah, so, in a lot of climate discussions, there's this dictum that says you can't manage what you can't measure, or you have to manage what you can measure. And this really speaks to, what we're trying to do, which is to give a clearer idea of what are the challenges. But I'm not entirely pessimistic. in this age of, and what we've talked about earlier, right, social media, people getting online, you can actually crowdsource a lot of the solutions. Like for instance, where in very remote areas, you use sensors, or where there are communities, then you encourage communities to crowdsource the information for you when a fire happens. Take a photo, report it to some authority or other. And that's one way that we can, mitigate some of these challenges and find better solutions to it. Before I go to the Q&A, maybe I'd like to start with a couple of questions for our panelists while you take your time to think about what you want to ask. Matt, when we talked about how, climate change can increasingly impact future fire and haze risks, how do you think you can track better the climate variability and the kind of impacts over the coming decades? Because in our study, we have not involved any meteorological experts. We have not taken in projections downscale to the region and to the country or to the province or the sub-district. So how then can we track this variability better? Because it relates to the next question about how can we inform.
So let me just check I understand the question, Sharon. So this is about the potential of climate change to affect future fire risk and tracking it better or kind of predicting it better?
Predicting it better.
So I mentioned in my presentation that at the moment the risks and the likelihood of fire is very strongly tied to climate variability, okay? And these can be natural forms of climate variability. So the El Nino Southern Oscillation is a very prominent and influential form of variability with El Nino phases, which promote dry conditions in Southeast Asia. There are other types of kind of natural oscillation. For example, the Indian Ocean dipole. So I think this was quite a prominent factor in the quite large haze we had in 2019. That was not an El Nino year. And there are kind of smaller scale phenomena as well that occur naturally. And so one of the big questions is just whether climate change will affect these natural oscillations. So will it change the characteristics of the El Nino phenomenon? Might we have more frequent El Ninos, or might we have, let's say, bigger amplitude or bigger size El Ninos? And I think this is something that maybe I just put in a caveat. This is not exactly my research area. I'm not doing research directly on this, but I believe this is still rather an open question. I've seen some papers suggesting that we could have bigger El Ninos or more frequent El Ninos, but I think this is far from certain. So this is about whether climate change affects these natural climate variations. And then there's kind of another factor, which is that in general the climate will warm, will be promoting more evaporation, evapotranspiration in these warmer conditions. And so I think maybe the big risk would be that we have the combination of these two things, right? We have the long-term warming trend on top of potentially bigger or more frequent dry episodes, right? So this would then lead to something which is not within the current bounds of variability, right? It would be unprecedented. It would be new kinds of climate situation. And so I'm not saying this will happen. I'm just saying it's a risk, and I think it's still a scientific question. But it would seem to me that it's sensible to consider that risk in thinking about peatlands in the future, right? The conditions could be outside of what the historical conditions have been. So I think I would put it like that. It's scientifically uncertain, but there's a potential for some new or larger type of risk due to climate change.
Yeah, and as far as I know, there's been a study as well done by the Center for Climate Research Singapore, projecting the patterns of weather variability for Southeast Asia, and perhaps someone might be keen to pick up that conversation on how to use that data or the projections that they have, because we talked also about early warning systems in the future, and that's one of those points.
Sharon, if I could just add to that. So yeah, I think probably I answered the question from the perspective of what could happen over decades, right? Long-term climate change, but I think the issue of kind of shorter-term climate prediction, early warning systems, this is also very important. But I probably didn't cover that in my answer. Yeah.
And also in your presentation, you talked about deploying nature-based solutions, but you said that these solutions were not deployed at scale. Can you explain a little bit what kind of difficulties there are in deploying these solutions?
So I think I'm probably in my presentation really kind of large-scale targeted interventions being deployed sustainably. I think we over a longer time scale, I think we haven't seen too much of that yet. I think one of the big fundamental challenges relates to maybe Alex's presentation, in that it may not be very clear what we can expect outcomes to be. There's just these different layers of uncertainty, and it therefore makes it hard to kind of look forward what would be the outlook for this kind of project. And I guess what we, and in Alex's presentation, what we are saying is that there is lots of uncertainty, and we can do some things to try and reduce it, but I think to imagine we can ignore it and remove it is probably not realistic, and so we need to try and maybe embrace the uncertainty and acknowledge it and factor it into the plans. Yeah. So I would say, just being not entirely clear on what outcomes we can expect, and maybe less awareness of the large potential could be a factor there.
Thank you.
Maybe I think Matt brought up a good comment which makes me reflect some important things I didn't say in my presentation. It's that if we're more uncertain in terms of the outcomes, if we use a precautionary principle instead of imagining, so a nature-based solution, a classic one might be some sort of restoration activity, and then we go, okay, this many hectares equals this much greenhouse gas sequestered. But what we're discovering all across the world is some of these projects aren't doing as well as we thought, because the science is very new to understand, how does it take a decade for trees to start really absorbing climate? Recent studies have shown that at the very beginning of restoration, actually these locations are actually greenhouse gas emitters. So we're learning more about the science of restoration and how these restoration interventions actually will, for example, mitigate and absorb greenhouse gas emissions. So what we need to do is embrace uncertainty, as Matt said, but perhaps that means, the total intervention areas need to be larger to make up for the fact that there's perhaps greater uncertainty. So rather than maybe at the moment, when we look at the bounds of error, we're perhaps choosing the most optimistic scenarios around our nature-based solutions, saying, this much many trees planted will result in all this greenhouse gas absorbed. But maybe if we include uncertainty in that calculation, maybe we might need to multiply, the size of these interventions. So that's a way in which these kinds of uncertainty in measurement can be accounted for in intervention.
Very interesting. Policymakers and markets don't like uncertainty. They like certainty and signals. So as you were doing your presentation just now, I was thinking, is there an internationally recognized grading system of peatland quality? Like, do you grade your sugary drinks in Singapore with A, B, C, and D, right? Is there any way that are there studies done to tell you this is quality peatland versus, down the spectrum will be terribly degraded and then...
I'm not sure about the exact mechanism or the exact measurement system, because I suspect it depends on... So we do measurement, for example, if you're the stock market in Malaysia, for example, they'll do some sort of estimate of their impact for their ESG assessments. If you're RSPO, you'll have your own measurement of conditions. So I would assume there are a lot of different ways in which and grading of peatland, but there's definitely lots of measurements and ways in which we would measure the peatland condition from, the height of the peatland, the depth of the peatland, the amount of water within the peat soils, the biodiversity found within those peatland forests. So there'll be a whole host of different metrics that people will choose or not choose. So if you're the stock market, you probably have some really simple measurement, but perhaps if you're a scientist who does conservation and biodiversity, your metrics or your way of measurement will be hopefully much more precise and include many different variables.
Yeah, but as an investor in an NBS project, for instance, it's useful to have, like a harmonized standard to say, okay, I'm investing in a grade A peatland project versus a grade D project. I
think definitely, and this is not my area, so and the area is hugely complex, but there's a Vera assessment, for example, that's being used as well, and yes, so definitely those exist. But the challenge is, in a way, the companies, governments want products, to be bought and sold, like in terms of carbon trading and so on. But the science needs to keep up with that. So I think we need to get more accurate and better at estimating things like condition. But in the meantime, we need to include the uncertainty around our ability to truly measure thing and grade, which, as you said, is something that no one wants. People want certainty in their investment. So this relates back to Az's stuff. There's the communication of this is a real big challenge.
Yeah, that's right. I'd like to open the floor now to the physical audience, because we have some questions coming in from our online audience. So if anyone would like to ask a question, yes, Dr. Christopher Lan.
Good morning, everyone. I'm Christopher Lan. I'm a visiting senior fellow from the Climate Change in Southeast Asia program. So you were talking about policy and markets, and in that regard, there's an increasing trend to look at nature as an asset, right? So when we look at the peatlands, they provide multiple ecosystem services, carbon storage, biodiversity, habitats, water regulation. So I was wondering, following the conversation you guys just had, is there any comprehensive economic valuation framework in looking at peatlands? Like, how do we actually quantify their value in a way, in monetary sense? Whether there's been an attempt to look at it from a very comprehensive point of view, not just say from narrowly carbon accounting. Yeah, thanks.
Who are you directing that question to?
Oh, to everybody, I guess,
Everyone,
because there are so
okay.
many different angles to look at the valuation issue, even from the point of view of communication, point of view of assessing of data. So yeah, anybody, thanks.
Okay, opening to anyone?
I'll have Ed. So I know, is it Robert Costanza? Who's the classic valuation scientist who has made some of the first estimates around, the value of ecosystem services globally. So I think, so I'm unaware of anything specifically for Southeast Asia peatlands, but I know there are lots of, like you're saying, so there might be a carbon-focused, framework for investors, and I think there's a lot of different overlapping frameworks. There's the high conservation value, HCV, for example, framework that's out there that's used as part of the RSPO assessment, which includes biodiversity as well as a range of ecosystem services. In terms of conversion to monetary value, I think I haven't heard of anything very concrete. I can imagine the red plus. I won't give it a go of unpacking the acronym, is used throughout Borneo. I know Norway, for example, has made quite massive investments. But I don't think, and I think that's a lovely thing to focus on, I don't think that overall value of all the different ecosystem services. So, for example, timber, value to communities, spiritual value even is really critical, relationship values, plus the classics like greenhouse gas emissions and things. I don't think that's been put together. And more widely, before I stop, I think that's the challenge, right? Because grey infrastructure is very simple to value, and we've had hundreds of years of engineers and economists and so on, managers who have been able to go, this is what the value of a dam is. And, that's much easier than to think about, here's the value of the forest that would, by conserving the forest, we don't need the dam, because it's not as simple, the calculus for that. And I think it's a challenge, eternal challenge.
Okay. Yep.
Yeah, I just might add something very briefly. I agree with what Alex has said, and equally I am unaware of any kind of comprehensive, multi-dimensional kind of valuation system for peatlands. But I could imagine if one exists, someone in our audience would hopefully tell us. But I might also just point forward to the next presentation we will have from Dr. Helena. So the third recommendation in our policy brief is valuing broader sustainability benefits. And so I think Helena would touch on this more. But in the end, in our research, we have not come up with that valuation system. I think that would be a big challenge. But I think this kind of question is really important. So thanks.
Thank you. Yes, Indira?
Thank you to all the presenters for the very informative presentations. My name is Indira. I'm a research officer at ICES. I have two questions, both for Dr. Azliyana, if I may. The first one is, I think you mentioned in your presentation that the highest media mentions of haze and climate change occurred in 2019 and 2023. In both those years, for Indonesia, 2019 was a presidential election and 2023 was leading up to the latest presidential election year. I wonder if you could share more about the framing of how the media mentions were and if there were any differences compared to the across the other years. And then my second question is, in 2019, I think YouGov released a survey that found that Indonesia has the highest number of climate deniers. So 18% of people believed in climate change, but not in the impact of humans on climate change.
80 or 18?
18. But it was the highest across the countries surveyed. And I wonder if you asked any questions in your survey about the anthropogenic climate change and haze in particular. Thank you.
Thank you so much. Sorry. Thank you so much for the question. I have some. Sorry, I need to pull up some. Yep. So you were asking about 2019 and 2023, how it's related to the presidential in election in Indonesia. In the 2023 articles, we have noted that it was the year being the highest number of reports because there's a letter that was sent from Malaysian government to Indonesian government stating on haze. There was an official letter from the Malaysian government to Indonesian government, and this letter is seen as Malaysia blaming Indonesia for the haze situation. So that is so the frame of those mentions in that year is more or less an uproar of why this is happening. And because we also know that the companies that are causing haze in Indonesia, yes, the land burns in Indonesia, but the company are Malaysian companies. So there are a lot of things around there that different statements that are being made because of that particular letter. In 2019, I think there's also, because there's haze episode that is in that year. I'm not sure if it's during the election, there's a lot of other mentions around haze and how it's maybe because it's the year of presidential election and the year of haze happening, so there's some coincidence reporting in and also some campaigns that are being used, but I'm not aware of what are the entire framing that they use in that year particularly. But there is a note that there's hotspots of haze in Sumatra and Kalimantan in 2019, which are the main reasons of media coverage in that particular year. So for your second question, is this the public survey that ISIS in 2019 in Indonesia? So in our survey, we did ask questions on whether or not they think this is happening naturally or happening because of human activities. So in Malaysia, because the survey that I shared for Indonesia is not something that we do, it's a report, but for Malaysia, we do have questions that ask if they think that this is naturally occurrence. Yes, this is climate change, but is it naturally occurrence? This is climate change, but it is majorly anthropogenic. So in Malaysia particularly, I think, I can't remember exactly, but there's a high number of respondents that think that it is anthropogenically contributed by human activities. Yeah.
Okay. Thank you. If there are no other questions, I'd like to move on to the online questions. And this is one for Professor Lechner. This is from Ronel Giam. He is our ISIS GIS expert. He wants to ask, given the scarcity of ground truth biodiversity data in our Southeast Asian peatlands, how do you assess the transferability of specific species distribution models, SDMs? This is technical, I don't know this term. Trained in one peat dome to neighboring domes with different disturbance histories, hydrological conditions, or microtopography. And his second question is your thoughts on participatory community mapping in the two countries we discussed compared to the global north where GIS is more accessible.
All right. So the first one's quite quite a super technical question around the application of species distribution modelling. And the idea is with species distribution models, you have field data where you observe, oh, okay, this tiger's found here. Oh, we found another tiger here. So they're observation-only data, and there's no absence data. So we try to associate those locations where we find the species occurred with the environmental conditions. And the question is that maybe you did I'm guessing this is, you might do a survey in areas that are easily accessible. You know, are they transferable to areas where they're less accessible if you had some remote sensing data and, you know, data on topography and so on. So, I think generally that challenge is quite huge, and it will vary dramatically. So that's kind of a non-answer from me. That it all depends, but with species distribution modelling, there are ways in which we can characterise that. But I think it also, maybe if I step back more broadly, this question relates to also there's this challenge. So, for example, you could probably, if you're measuring all the ecosystem services and, you know, doing a comprehensive valuation, you could probably do that at the forest level and you could get a number. But if you did it more broadly for Southeast Asia, you'll get a very different number, but maybe it won't make any sense at the community level. And I think that's the same. It's a similar kind of challenge outlined here. For the second question around, I think there's so much data. If you look at the EU, there's amazing data online, and I do work in Finland, and we're like, which data set shall we choose? And, you know, we've got this really high quality 5 metre data set that's 1 year old, all this other high quality data set that's only 3 years old, some are better. So I think the whole participatory community type mapping, you know, has huge potential in Southeast Asia and Indonesia in terms of acquiring, because field data is perhaps the most laborious to actually get. And, in Europe, labour is super expensive, so there's a huge focus on remote sensing and all this kind of stuff. But I think in Asia, in Southeast Asia, there's, huge opportunity to pay communities. They should be rewarded for that data because it benefits the whole world when we can map our peatlands better. So I think, voluntary and paid participatory community mapping is huge potential.
The Global North data sets that you talk about, this huge buffet, who invests in getting those data sets? The governments?
Yeah, the governments. And it might be at the local level, local councils, provincial level. And so there's a range of overlapping in terms of different kinds of quality. So, and then, of course, there's EU-wide schemes and fantastic data sets. And maybe this links, and the EU and the US, for example, they produce global data sets, which are often the ones we might use in Southeast Asia. Fantastic global land cover map. The challenge is, for example, some of these global maps, they won't include rubber. They don't include oil palm or some of the really critical land covers, or they'll call it all agriculture. So we really need to build, our network and, in Southeast Asia to create our own locally specific data sets for this globally important area, I think.
And to make them publicly available.
Yeah, exactly.
And accessible for use, not only just by researchers, but also, by the communities and by the general public. Because I do think that governments do collect their own data, and maybe they are bound by certain regulations not to be able to share that publicly, right?
And maybe I can just quickly add, I think EU and the US, for example, have much better open, transparent data policies which don't exist, especially in Malaysia, and less so. Indonesia is better than Malaysia. Sorry, Malaysia. But just as an example, in the US, I think it's policy that any data produced by the government is paid for by taxes and therefore should be open to everyone.
Yeah, that's right. Yeah.
Yeah.
So back in the day when I used to work on the transboundary haze issue and monitoring hotspots, there are always these limitations because the satellites that come around this region, right? They do certain passes and at higher or lower resolution, and of course it's very expensive to acquire these maps. And once you acquire it, then of course you want to be able to use it and enable more people to use it. Okay, we have a second question, and I think I will open this question to both Matt and Alex, because the question is about definitions of peatlands. Is there a definition of peatlands as influenced by national governments, and how do they differ between Malaysia and Indonesia? So this person, Ying Shan, says that, for example, in the forest sector, the FAO adopts a certain definition of 10% canopy cover, whereas some national governments choose 20% for their own reasons. So I think just now we did talk a little bit about how palm oil plantations cannot be counted as forest cover, and we're going into the area of land use definitions.
It's a hard question.
Yeah, thanks, Alex. So, in Alex's presentation, you did show a table of estimates of total peatland area in Indonesia and in Malaysia. And among those estimates were official ones or semi-official ones. I think that the government says this is our official peatland area, and those areas may be used, for example, in the reporting of greenhouse gas emissions to the United Nations. And in that table, we did include some information about the definitions, and I think Alex made the point that the definitions can vary, different assumptions about the depth of the organic soil and so on. Off the top of my head, I do not recall what the official definition is in the two countries, though, and whether it really is written down as an official definition or whether it is just what was used for those area estimates, I'm not sure. I don't know, Alex, you want to add to that?
Maybe to more broadly add to that, I think my original research area was uncertainty in remote sensing. And in a way, we really don't know. A forest is an abstraction of the real world. So it's how we abstract. So if the question around FAO definitions, so it could be, 10% canopy cover.
And choose 20%.
Yeah. So if you're in Australia where you have these forests which are super open and dry, you need to make your canopy cover value quite low in order to call it a forest. But if you're in a tropical forest, you need, forests are generally super thick and there's no gaps in the canopy. Therefore, the definition of what in a forest in the tropics is slightly different. So there, as well as perhaps there being nefarious reasons, because you may want to under or overestimate your forest for various reporting, there's also this sort of conceptual what is a forest challenge as well. And that's why I'm always saying, it's not that things are wrong, they're just uncertain and need to be more transparent and so on.
Okay. Thank you. We have a question on ASEAN, and I think one of our members of the team, Dr. Varkkey, might be able to answer this question. This is from Kun Apichai Sunchinda from Thailand, and the question is that, ASEAN has now come up with an investment framework for haze-free sustainable land management, which will incorporate peatlands. And it includes an investment figure of $2.2 billion from 2023 to 2030. Does this figure make sense to you? And if so, how feasible is it to obtain such funds? And is the money the main constraint, or other enabling factors should be in place to achieve a successful outcome in this investment framework? Would you be able to take that, Helena?
Okay, thank you so much. Thanks, Kun Apichai, for the question. And I think this question relates quite nicely to what our final conclusions are in our policy brief. So one of the things that we are proposing actually is to have a sort of harmonized standards between how all countries in ASEAN kind of look at their peatlands and value it. And we do have the ASEAN Peatland Management Strategy 2023 to 2030, which does encourage this sort of harmonized data practices. So I think this ties in quite nicely to what ASEAN is trying to do in terms of haze and fire management through the investment framework that Kun Apichai had mentioned. And the figure that was mentioned in the framework, 2.2 billion, of course, it seems like a huge figure, but it ties very closely to what we have looked at in terms of like carbon financing, carbon credits, and the fact that we call attention to the issues that come into when we acknowledge these uncertainties that Alex and Matthew have mentioned. Because when you do have uncertainties, when there are these issues, we have the sort of knock-on effects of how investors look at the assurance of investing in our region. So when we do want to drum up interest in this kind of really big amounts, Malaysia, Singapore, Indonesia, the way that we value our peatlands need to improve so that there will be reduced risk to the integrity of the carbon credits that are being offered. So I think it's part of the whole conversation. As we move towards being more acknowledging all of these challenges, it has to be written into how the carbon credits are valued, how the integrity risks are considered, and what kind of things are actually being valued. So if we move beyond sort of carbon crediting into more of biodiversity standards, which I hope I'll have a bit of time to talk about later, I think that can be incorporated into what are the requirements or what are the options for investment within the ASEAN investment framework. And when we sort of open up these definitions and open up these, integrity risks and all that, the conversation, hopefully there will be more space for investment beyond this very narrow sort of carbon-linked definitions that we've had in the past. So I think this project that we are, one of our final big outputs is to sort of call attention to that, to get people to be more open to this idea that there's a lot more than just carbon valuation. And when people are more sensitized to this idea, hopefully there will be a lot more space for investment to come in based on these other very important guidelines as well. Thank you.
Sorry, I was just saying that I'd like to leave some time for Helena to go into her presentation later. But before we go off, I was actually really very fascinated with Dr. Azliyana's study because just to do a shameless plug for ISIS, we do a survey on public perceptions on climate change, and we've done this for 5 years. And in fact, some overlaps in your numbers, right, between those who are climate conscious and those who are deniers. And we definitely see some discrepancies in what they do in adapting their personal lifestyles to the level of concern that they have. But what I also want to know from you is that those social media has really provided a way for us to amplify those concerns, amplify those the research that we have. Social media is a double-edged sword. It also comes with the dangers of disinformation and misinformation, particularly in this area of transboundary haze pollution, fires, and so on. How do you counter that?
Thank you so much, Sharon. Like what we found was social media is where people got attention to information from. So if you ask anyone, where do you get your information from? I think previously it was Google, but now it's TikTok. And on TikTok, it's freely, information is freely available, whether it's correct or incorrect. I would say that it's it's a multifaceted. It has to be coordinated. I think, it's particularly in Malaysia, we are highly entertainment country. People tend to be more interested in entertainment. 90% of our TV is entertainment. That's why, and I think that's one of the reasons why people has tracked from getting information from television to getting information from our mobiles. So there are really good influences out there that and civil societies that we as researchers could partner with to create content that are digestible by lay people. And there are also efforts from different civil societies that I've seen around smaller scale for young journalism, community journalism, and true information that are gonna get through. But this information needs to be sourced from the right people. I'm gonna also, maybe one good example is last year when there's a landslide, sinkhole in the heart of KL that caused the tourists to they didn't find her until in the end. And right after, there's a AI generated figure that was being spread like wildfire, that says that under the KL skylines are actually karst limestone caves right under KL, and that sparks really. Of course, it's scary when you read it, but there's a fine print in that caption that says this is AI generated. But before that fine print, that says it says that researcher from University Malaya named so and so, but that name is not someone from University of Malaya. But people don't read the fine print, so it got spread by like wildfire. But UM's effort in saying no, this is not true, doesn't spread as wild as the first news. So those kind of things, it's added work for the geologists in UM to actually, no, this is not what it is. This is, we don't have this person in our department and things like that. But that is one example of disinformation. It's blatantly created and there's thousands others out there. So information from us, researchers, scientists, people who work in the area needs to get to out there in the information, and those information needs to be the basis of the influencers that created the stories that people are trusting.
So this unfortunate truth is that untruths sell better than truths. I think we'll come to the end of this panel. We do have some questions online still. Unfortunately, we can't go to them, but we'll make sure that the panelists give you a written question. So if you have any more questions, please feel free to just put it on the Q&A. So with that, please give our panelists a big round of applause.
Thank you, Sharon and panelists, for your generous sharing and astute remarks. May I invite the panel to take their seats in the audience. Today's policy brief will be launched by Dr. Helena Varkkey. Dr. Varkkey is an Associate Professor of Political Ecology at University Malaya. Her areas of expertise include transboundary haze governance in Southeast Asia, global palm oil politics, and climate politics and governance. Her monograph on the haze problem in Southeast Asia, palm oil and politics was published by Routledge in 2016. She's the principal investigator on the APN project, Policy and Governance Approaches to Cooperative Migration of Peatland Carbon Emissions and Transboundary Haze in Southeast Asia. Without further ado, may I please invite Dr. Varkkey to the rostrum to speak on her policy brief. Dr. Varkkey, please. Yeah, so you can speak.
Okay, thank you so much. Okay. Yeah. Okay. Yeah. Okay. Yeah, not Sharon. Okay, thank you so much everyone for staying with us until the end. So this is just the final quick section. And I am here very grateful to all of you who have come to listen to us. I think this is something that what Azliyana has said, yeah, we need to share information about how science came to know the facts. So I think this is part of that mission. We have done our research for 3 years, and this is one of the final dissemination sessions to you all in the room and to those of you online as well. We are very grateful that you are interested in the work that we are doing. And of course, I'm very grateful to my team as well. We work really well together, and I really appreciate all the time spent on this project. And ISIS for supporting us, as well as all of the respondents, the interviewees, the community members that spend a lot of time with us. Some of the organizations that helped us are actually in the room today, like PM Haze, so we really appreciate that. And you all have in front of you, I hope, the policy brief that we have developed as a result of the findings that we have been able to extract or we have been able to conclude in our 3 years. Yeah. So this policy brief is mainly based on a few published and unpublished data set or papers, two of which, one of the books that you have in front of you is sort of our literature review of the baseline of information. And we also have some commentaries that have already been online. But two important, hopefully upcoming publications that I would like to mention for you to watch out for. The first is very much based on the paper that Prof. Alex had gone through with all of you. We are hoping to be able to publish it in a journal very, very soon. And as Prof. Alex has mentioned, some of the people who were involved in the workshop for that are also part of the writing team. And we really appreciate their contributions on this. And the second one is actually a chapter that will be published in a book about ecology and the management and governance based on a more ecological approach, ecosystem services approach. So that one is more towards the role of the community and how communities are an important part of the consideration and the conversation as well. So what I have here is basically just a quick summary of what has already been shared, but I will just go through quickly and hopefully during lunchtime, if we have some time, we can also have a bit of conversation about this. So basically, our project started from this looking at the trends of what was influencing peatland policy in the region. So if you look over time, we can see that in the beginning, very much about conservation, the idea that peatlands are an important conservation area that countries needed to look into. But when fires and haze started becoming a very important problem in the region, policy making on peatlands kind of moved in that direction, unsurprisingly. But today, what we see is that actually policy is very much sort of linked into this important tie-in between climate and peatlands, and is very much looking into how countries can actually integrate peatlands into national climate strategies within global frameworks. So things like the NDCs and all that, peatlands have become much more prominent in calculations, in policy making, and in also governance measures. So land-based carbon emissions and removals have become crucial considerations for our countries in our region towards achieving their net zero goals. So we can see a lot of countries like Malaysia, for example, removals is a very important part of the calculations. However, as we have heard previously, the data related to these peatlands can be limited, contradictory, can have issues with accuracy and all the other things that Alex has talked about, which can weaken policy and governance decisions. So our policy brief, which I hope you have already had a chance to glance through, we will sort of just highlight again the gaps that we have found in our research in terms of the use of evidence for policy making, both from the data and the community perspectives. And we are hopefully offering some useful recommendations for policymakers around the regions for their consideration. So the first gap, very much based on the data research that we have done as part of our project, comes from the sort of, I guess, important consideration that policies that ignore data uncertainty can lead to poor and potentially biased decisions. So to just alert policymakers to this importance of acknowledging data uncertainties. So some of the issues beyond what has already been mentioned earlier also come additional issues like mismatches in jurisdictional and biophysical boundaries, issues of land tenure, all these kind of things can lead to discrepancies in or uncertainties in things like peat hydrology, peat extent, and all this as well. There's also the issue of data access or transparency. So limited access to official spatial data means stakeholders other than the government, which can include investors, which can include markets and all that as well, they must use inconsistent and non-standard data sets for scientific analysis and also management decisions. So these are kind of the additional issues of data that we have also found in our research. And the table there comes directly from our paper that's going to come out soon, hopefully, as well as the policy brief. It actually shows a comparison of the data sets used for Indonesia and Malaysia, as well as UNEP as well. So the interesting thing, if you can look just at the final row there, we have a comparison of the official data set numbers compared to what it would have been if the UNEP figures were used or the UNEP data were used. So you can see there is quite a big difference. If the UNEP values replace the values in national emissions inventories, national total net emissions would increase by 14% in Indonesia and by 34% in Malaysia. So it really does matter which data sets are used, and especially when there are the issues of transparency, this is amplified as well when governments are unable to share what they are using and what parameters they are using as well. The second gap is about community knowledge, and what we have found through our fieldwork, there is an undervaluing of this community knowledge. The picture that I have shared here is actually part of our exercise that we did in our community focus groups, where we actually asked the community to identify their priority areas. And not only that, we asked them to actually sort of value it as well by putting the stickers accordingly. So you can see that there is an acknowledgement of many issues, but the importance is different. And some of the interesting things, if we want to go even more deeply into our data, we had also divided our community members into male and female groups, and the reflection of the difference in prioritization is also does have a gender difference as well. And this is more further discussed in our chapter that I had mentioned earlier, which focuses more on the community. So what we found that when we had our interviews with policymakers and policy adjacent stakeholders, they actually said that the community doesn't understand climate change. Climate change is too complicated for communities to understand. So we found this a bit worrying. So we went to the communities and we asked them, is it true that you find it difficult to understand climate change? And actually they did agree. They said that climate change is difficult for us to understand. It's something that is very hard for us to wrap our minds around. However, communities do have a good understanding of other things which policymakers may not have a good understanding of. So for example, they have good understanding on the causes and effects of fires on peatlands, which for a long time policymakers didn't have a good grasp of. So even though there may be areas that communities do not have a good understanding, there are other areas. And what we found interesting on this was that just because they do not, there will be maybe certain areas that communities do not are struggling to understand or to comprehend. It doesn't mean that they should not be considered at all, or they do not have any value, anything of value to offer policy making. There are certain angles that they do have that good understanding, and just to exclude them because you think that they're not able to comprehend climate change is actually missing out a big area, especially as we have heard Matt has talked about, there is a big link between fires and climate change anyway. However, of course, official documents do note the importance of community input, local wisdom. This is in line with, of course, global trends of FPIC and stuff like that. So because there is this is in line with the international trends of really prioritizing or centering community input, since they are the ones who are on the ground. However, in practice, what we have found by speaking to the communities as well as the policymakers, again in the spirit of, communities don't really understand, sadly, what has happened is that a lot of the policy making around peatlands are top-down. And this actually hinders community buy-in and can result in unintended outcomes. So, which comes to our recommendation, and our big conclusion is that given the already long-standing scientific efforts to measure peatlands, which is what we saw in Alex's sharing, uncertainty in peatland data is unlikely to be quickly resolved through further measurement alone. So if we just want to resolve the issues of data uncertainty by doing more measurements, this is probably not the way to go. So our recommendation, instead of that, is we are focusing on addressing the identified gaps through the supplementary and complementary use of scientific evidence together with community-based evidence. So sort of giving them equal or complementary importance. So which comes to my 3 recommendations. The first is about enhancing data practices across scales and borders. So as mentioned, data sets need to be fit for purpose, incorporating uncertainty with error margins and uncertainty bounds, as mentioned, and also importantly, transparency, as I had discussed earlier. And this has to be complemented with community-led monitoring, MRV basically. And this is also important to foster data accuracy, ownership, and culturally appropriate information, and building trust in community-managed areas. So this is will be very important towards ensuring the stewardship in the long term. And I've mentioned as well about data harmonization at the ASEAN level, but also at the local level as well. And this is important because we have seen the importance, or rather the increasing importance of carbon credit projects as a way to fund certain projects as well. So that is our first recommendation about data. And the recommendation 2 is also related to data, but more about incorporating it in a more effective and a more open way with the trends towards carbon markets and carbon credits. So as mentioned by Matt, there is an important opportunity here because Southeast Asian countries are extremely peat rich, but not as many carbon projects are existing at the moment, so they are a bit undersubscribed. And this is also related to the fact or the fact that there is a lot of data uncertainty here. So because of this, future carbon performance is complicated by the uncertainties of baselines and ambiguous intervention outcomes, and this can discourage investments and hinder quality assessments and increase the risk of having good crediting systems. So there is now, especially since our countries in our region are in the development phase of our various carbon markets, including Singapore as well, which hopes to be a regional hub actually for climate or carbon credit trading. There's an opportunity to adopt maybe approaches that are a bit different from the rest of the world, which try to foreground uncertainty a bit more and are grounded in the precautionary principle. So there could be directions like issuing credits based on retrospective impact, designing risk-stratified credits, and also looking at payments not only for carbon, but also things like ecosystem services as well. And importantly also, we need to look into adopting more community-friendly MRV approaches because a lot of the carbon credits, they involve community time and effort and investment sometimes as well, very literally. So in order for the communities to get their returns more quickly, this is important to ensure that communities stay interested in carbon credits and in taking care of the ecosystems that they are in. And this could also inform the development of the ASEAN Common Carbon Framework that is currently in development at the regional level. And finally, our third recommendation is valuing broader sustainability benefits. So this was related to some of the questions that were asked earlier. So one thing that we found interesting during our interviews and our focus groups is that sustainability means different things to different stakeholders. So when we talked about sustainability to policymakers, it's the very sort of mainstream understanding of sustainability of ecosystem services or the environment. But when we talk to peatland communities, what they understood by sustainability was sometimes or often very different. So they highlighted problems of sustainability of things like programs and assistance provided by external parties, by governments, by NGOs and stuff like that. This was what they were concerned about in terms of long-term sustainability. And also, of course, income certainty. Of course, sustainability of the landscape was important as well, but it was tied up to these other things that were very important to them as well that wasn't really on the radar of policymakers. So what we have concluded or what we want to recommend is that policy and governance mechanisms for peatland areas should not be over-dependent on their carbon potential alone, but it should take the consideration of the peatland community's value of the peatlands. And we call this the contributions-based approach. So things like moving away from emphasis on projects framed around carbon outcomes, which may be precise, but then again is also uncertain as we have seen. And we also need to look into embedding more locally relevant biodiversity indicators, fire risk metrics and socioeconomic data and the likes. So for example, we do have some guidelines. For example, Vera has their climate community and biodiversity standard, but even that, it still treats carbon as primary and other things as additional. So there is an opportunity here to integrate carbon and other indicators more equally and with equal weightage to reflect better the concerns of the peatland communities. So again, linking to the knowledge that is there with the communities about fire risk, about fire management. These are all really important knowledge that the communities have that really can contribute directly to their livelihood sustainability. And this could be a way forward in engaging communities about climate, about carbon, but through a much more locally relatable issue. So those are the 3 recommendations that our project has come up with. So I hope that you all in the room, as well as policymakers who hopefully will be able to access this, and we will try our best to share this with as many policymakers around the region as possible. It will be useful for future planning and development in this area. So thanks again to my team, thanks again to everyone here, as well as thank you to our funders as well from APN. And also thank you to Azliyana for joining us here. Thank you very much. So I will end here, and I hope everyone can join us for lunch and we can have a more chat about all of this. Thank you so much.
We have now come to the end of the event, and we hope you have enjoyed the discussion. To our in-person audience, please feel free to join us for lunch, which has been set up outside this room. Thank you, everyone, and have a nice day.